Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how we can be sure that social and emotional learning programs actually help kids? This new paper dives deep into that very question. So, the researchers here were really interested in understanding which programs actually help students with their social and emotional learning, or SEL. You know, things like managing emotions, building relationships, and getting along with others. It is super important for kids to learn these skills, but figuring out if the programs designed to teach them are actually working is tough. To do that, you need really good studies, and those studies need to be planned carefully. A big part of that planning is something called a power analysis. Think of it like this. A power analysis is like asking yourself, do I have enough people in my study to actually see if my program makes a difference, or will any tiny effect get lost in the noise? To do a good power analysis, you need some key numbers. These are called design parameters, but it turns out there aren't many good reliable numbers out there for SEL research, especially for students in different age groups, and when different people like teachers or parents are rating the kids. This paper's big contribution is creating a massive database of these essential numbers, called design parameters, specifically for SEL research. They start by saying that teaching SEL is a really big deal globally, and a lot of schools are trying to do it, but they point out not all these programs are winners, and they don't all work the same way for everyone, so they really need more solid research to help us figure out what works best and how. And when it comes to proving that something works, randomized experiments are like the gold standard. They're the best way to be sure that any changes you see in kids are actually because of the program and not something else. But, as we mentioned, planning these studies is tricky. You need to know things like how much variation there is in SEL skills among students, or how similar kids in the same classroom or school are when it comes to these skills. Without good estimates of these values, called design parameters, your power analysis is just a guess. And your study might be too small to find a real effect even if there is one. Previous work has focused on younger kids or only on student self-reports. So this team decided to create a more comprehensive database using data from German students across grades 1 to 13. And they looked at assessments from students themselves, their parents, and their teachers. This section breaks down what these design parameters actually are and why they matter for planning research. They talk about different ways you can design an experiment. There is a simpler design called an individually randomized trial, or ERT. Imagine you just randomly assign each student to either get the new SEL program or not. This is great for proving a concept, but it is not always what happens in real schools. Then they talk about more complex designs because in schools, kids are already grouped together. You have students in classrooms and classrooms in schools. So when you do an experiment, you might randomize whole classrooms or even whole schools to get the program. These are called cluster randomized trials, or CRTs. If you randomize whole schools, you need to know how much students within the same school tend to be alike in their SEL skills. If you randomize classrooms, you need to know how much kids in the same classroom are alike, and how much kids in the same school are alike. These kinds of group studies often need bigger sample sizes than individual studies because of this grouping, which is called clustering. This is where they introduce the main numbers they collected. The first big one is the intraclass correlation coefficient, or ICC. Basically, it tells you how much of the difference in SEL skills you see among students is due to them being in the same classroom or school. A higher ICC means kids in the same group are more similar, and this makes your study less powerful. So, if you are planning a study where schools are randomized, you need an estimate of the ICC at the school level. If you are randomizing classrooms within schools, you need both the school level ICC and the classroom. Level ICC, the other key design parameter, is the proportion of variance explained, or R squared. This is where covariates come in. Covariates are other things you measure that might be related to SEL skills, like a student's background, or how they were doing before the program started. Even if these things don't cause the SEL skill, if they predict it, using them as covariates in your analysis can help make your study more powerful. It is like tuning out the background noise so you can hear the signal from your program more clearly. They looked at 3 sets of covariates: socio-demographic characteristics like age and gender, baseline measures of the SEL outcome itself, and then a combination of both. For different study designs, you need these explained variance numbers at different levels: the student level, the classroom level, and the school level. So how did they get these all-important numbers? They used data from 9 large German studies that surveyed large representative groups of students from 1st grade all the way up to 13th grade. These studies used a multi-stage sampling design, meaning they first randomly selected schools and then randomly selected classrooms within those schools. This gives them data that is structured like real-world classrooms and schools. They looked at SEL outcomes in 3 main areas: self-orientation, which is about how you see yourself and manage your own emotions; other orientation, which is about how you relate to others, like empathy and pro-social behavior; and task orientation, which is about your persistence and interest in tasks. They also considered whether these skills were measured in a school context, like interest in math, or more generally, like personality traits, and importantly, they gathered data from student self-reports, parent ratings, and teacher ratings. They even give us the reliability of these measures, which shows how consistent they are. For instance, student self-reports had reliabilities ranging from a low of 0.33 to a high of 0.93, with a middle value of 0.81. They used the two-stage approach. In the first stage, they estimated all these design parameters for each specific SEL outcome within each of the original studies. They had to deal with missing data, which is common in big studies, using a method called multiple imputation. Then, they ran a bunch of statistical models for single-level designs. They used linear regression models to estimate the R-squared values for the different covariate sets. For the multi-level designs, those 2-level and 3-level studies with students nested in classrooms and schools, they used more complex models to estimate both the ICCs and the R-squared values at different levels. They importantly calculated these parameters not just for the general student population, but also for students in different academic tracks, because German schools have this tracking system. In the second stage, they took all these estimates from the individual studies and did a meta-analysis. A meta-analysis is like a study of studies. It combines results from multiple studies to get a more stable and generalizable estimate. They presented these meta-analytic summaries in 3 different ways, going from a broad summary across all SEL domains and contexts to a more specific summary within each domain context combination. This makes the database super flexible for different research scenarios. This section describes the actual database they created. It includes point estimates and these meta-analytic summaries. They also provide measures of uncertainty, like standard errors and confidence intervals, which are really crucial for planning. If you just use a single number, you might be missing the bigger picture of how reliable that number is. They've organized the database, so researchers can easily find parameters by matching them to their own study characteristics, like the grade level, the type of experimental design they plan to use, or the assessment method. This figure gives you a visual overview of their findings. You can see the point estimates from the individual studies and then the meta-analytic averages for different design types and assessment methods. For example, you can see the ICCs for different levels of education, or the proportions of variance explained by covariates for students, parents, or teachers. It gives you a sense of the typical ranges for these crucial numbers. This is really the core of the paper's message. They've built this database specifically to help researchers plan powerful SEL intervention studies. If you are planning a study, you can use this database to pick realistic values for your power analysis. For example, you can select the right ICCs to figure out how many schools you need for a cluster randomized trial, or choose R. Squared values for including covariates in your study. They even provide example scenarios of how to use the database for power analyses, showing how to deal with things like uncertainty in the estimates. They also encourage researchers to use these parameters for non-experimental studies too, where having good estimates is also really helpful. Now, like any good research, they are upfront about the limitations. First, they couldn't use sampling weights in their analysis due to software limitations. This means the parameters are representative of the specific student populations in their studies, but not necessarily every single student everywhere. Second, the data is from Germany, so while they hope it is useful internationally, they strongly advise caution when applying these numbers to other countries. If you are outside of Germany, you might want to look at estimates from other studies done in your own country or region, or maybe even conduct a small pilot study yourself. But if those aren't options, using their database with proper consideration for uncertainty is still a good way to plan a well-designed study. The great news is that they've made this database publicly available. You can access it online through links they provide. This is fantastic because it means other researchers can reuse their work and build upon it. They've also shared the R code they used, which is super important for transparency and allows others to replicate their findings or adapt the methods for their own data. And a fun little note here, they actually use ChatGPT for proofreading and language improvement. It is always interesting to see how new technologies are being integrated into research. For those interested, their research was funded by the DFG, the German Research Foundation. They also mentioned that the original data collection for the studies they used had all the necessary ethical approvals. So, what is my take on this research? Honestly, I think this is a massively important contribution to the field of SEL research. Planning planning studies, especially those involving complex multi-level or cluster designs, is notoriously difficult. Having a readily available empirically derived database of design parameters like ICCs and R squared values is an absolute game changer. It democratizes the ability to conduct underpowered studies. Researchers, especially those with limited resources or experience in large-scale data analysis, can now use these parameters to plan studies that have a much higher chance of detecting real effects if they exist. The meta analytics summaries are particularly brilliant because they offer robust average estimates that can be used across a range of specific SEL outcomes and contexts, making them broadly applicable. The fact that they broke down the data by academic track is also a significant strength, recognizing the structural differences in education systems that can influence student outcomes. And providing the data for different assessment methods, student, parent, and teacher is crucial because these perspectives can vary considerably and impact study design. Now, about those caveats, the lack of sampling weights means the generalizability outside of the specific German populations needs careful consideration, as they themselves noted. And the fact that the data is German means researchers in other countries really do need to be cautious. However, their R code being available is a huge plus. It allows researchers in other regions to adapt their methodology and apply it to their own national datasets, which is the gold standard for creating contextually relevant design parameters. I also think it is really clever how they've made all of this data accessible through interactive websites, allowing people to filter and download the exact parameters they need. Looking ahead, I'd love to see similar databases developed for other countries and perhaps for different age groups like early childhood or even university students. It would also be interesting to see if future research could explore the temporal stability of these parameters. Do ICCS and R-squared values change significantly over time within a country? Overall, this paper and the database it provides are a fantastic resource for anyone looking to conduct rigorous randomized intervention studies on students. Emotional learning outcomes. It directly addresses a critical need in the field and empowers researchers to design more effective and informative studies. What do you all think about the importance of these design parameters for planning research? Let me know your thoughts in the comments below. And if you found this breakdown helpful, please give us a thumbs up and subscribe to RUBIN'S Mind Lab for more deep dives into fascinating science. We'll see you next time.